Hello, design and analysis students. Welcome back. In today's episode, we're going to be looking at within subjects ANOVA. So within subjects ANOVA is used to compare group means on 3 or more outcomes. So there's a couple different ways we might use this test. In one example, we might be sampling the same individuals on the same measures at 3 different times, maybe before a treatment, after a treatment, and 1 month later. So the time is the within part, and we have the same individuals filling out the measures across time. Another way we might use a one-way within subjects ANOVA is if we had various aspects of an outcome for different individuals, and we wanted to compare them across these conditions. In the example we used in class, when we tried potato chips, you tried all 3 kinds, brand A, brand B, and brand C, and we wanted to see which one you liked better. So it was happening all around the same time, but we had 3 different kinds of chips. The third way we might use a within subjects ANOVA is for a match design. Perhaps we match males and females and transgender individuals within the conditions, and then we give them just one outcome, one level of the independent variable. So again, with matching, with repeated measures or repeated times, we would use a within subjects ANOVA instead of a between subjects ANOVA. How this is done in SPSS is to go to Analyze and General Linear Model, and this time, instead of picking univariate, which we can use for a between subjects ANOVA, we're going to pick repeated measures. So again, repeated times, repeated aspects of the factor. In this first example, I set up a factor to look at 3 different kinds of adjustment. So if I reset this, I would say, what if I was interested in looking at college adjustment and seeing if some part of it is harder than others? So maybe for my adjustment measure, I have 3 different levels or kinds. Maybe I want to look at whether grades is a harder adjustment than learning to be independent or living with a roommate. So for this example, I would put the factor name adjustment, indicate the number of levels. I'm going to look at 3, and click define. Once this is done, it's trying to show me in the within subjects variables which aspects of adjustment that you want. In this particular example, I'm going to see whether academic adjustment is easier or harder for students than learning to be independent and living with roommates or being comfortable with your living arrangements. So we can also use this general linear model if we've also got between subjects or we're doing like a multifactorial ANOVA. But today we're just going to do the within part and look at 3 different kinds of adjustment for people. Within this, we would want to go to plots and take that adjustment factor and put it on the horizontal axis. So we'll look at the means for academics, for being independent, for roommates, to see how they compare. And we'll add that. And then we can either do a line chart or a bar chart. When we're comparing group means, a line chart is more appropriate if we're looking across time, and that time makes sense to be continuous, or if we have an ordinal factor that we are using for our independent variable, maybe like class year, freshmen, sophomores, juniors, seniors, where we assume a kind of progression. So line charts are better for time or ordinal independent variables. A bar chart is better if the different conditions really are nominal and separate from each other. In this case, academic adjustment is different than learning to be independent, which is different than learning to live with a roommate. So a bar chart makes more sense than a line chart. Whatever graph we use, we want to include the error bars. The error bars help us see the variation within the group. So our graph will, when we make bars, will show us the variation across or between the groups. The error bars help us see the variation within. So we could see if there is more spread in one place than another within that factor. If we click continue, we will have it make a plot. We then want to ask it for post hoc tests or post hoc. That means after the fact. But wait a minute, Dr. Wickline, it won't let me do post hoc here. No, it won't with the within subjects. We have to get into a post hoc test with the estimated marginal means. So if we come into estimated means and select overall and adjustment here to display the means, it will allow us to compare those main effects between each pair in the group. We could either use the LSD condition least significant differences, which is the most flexible test, like you might expect for LSD, or we could pick a Bonferroni correction, which will be a little bit more rigorous. What a Bonferroni correction does is take the experiment-wise alpha level and divide it by the number of comparisons that we have to make. So in this case, we would take our alpha level of 0.05, and we would have to divide that by 3, because we have to compare groups 1 and 2, it's 1 comparison, 1 and 3, that's 2 comparisons, and 2 and 3, that's our 3rd comparison. So it takes that alpha level and makes it smaller, so the differences have to be even more precise for us to reject our null hypothesis and say something's going on. In this first example, I will show you the LSD, the more flexible approach, and then I'll go back and run it with Bonferroni so we can see how that changes things. Once you've got this post hoc option done, click Continue. And then we also want to go to Options and ask it to give us our descriptive statistics and our effect size. Effect size, if you remember, is a measure of how big the differences are, not their probability or likelihood for significance. So that's something that a lot of journals like to see too. They want to see the inferential result, and then the probability or p-value, and then an effect size, so we get a measure of the strength of the difference or the strength of the comparison. Click Continue, and now that we've got our factors in, our plots, a way to do our post hoc test, and our descriptive statistics and effect size, we can click OK. The first thing it does is tell us the order of the factors. So we put academics first, learning to be independent second, housing third. And it shows us the means and standard deviations that we'll need to report in making sense of our of our statistical test here when we're getting around to writing these results up. We'll need these means and standard deviations for each group or each level of the factor. The next thing we need to pay attention to, and some of this stuff you'll learn about in upper level classes, is the test of within subjects effects. This is where we're going to get our omnibus or overall F for our comparison. And we need to have 2 degrees of freedom. We need to have the between categories degrees of freedom. This is the number of groups minus 1. And then we have the leftover degrees of freedom. Everything else that takes us to explaining the variation between groups. So when you were reporting, we're going to start with assuming sphericity. You'll get into more in your upper level classes about when that may not hold. But we'll need this degree of freedom. We'll need this degree of freedom. And then it gives us our overall F value. In this case, we have a pretty big F, which leads to a pretty small significance level. Our p-value is really low, and when the p is low, the null hypothesis, the HO, has to go. So we will reject our null hypothesis and say, hey, there's a difference in here somewhere. The partial eta squared is a measure of effect size, and like Cohen's standards for correlations, 0.1 is small, 0.3 is moderate, and 0.5 is large. So in this case, we have a small difference between the groups. That is still really significant. We won't need to worry about the within subjects contrasts or between subjects contrasts at this stage of the game. The next thing we will need to look at is our pairwise comparisons. This is our post hoc test, and we see the same thing reported here that we do when we look at like an LSD, a Chaffee for a between groups design. It's taking each factor and comparing it to the other group. If the negative number appears, that means the first group is lower than the second group. If we get a positive value, it means that the first group is higher than the second group. So you can see these look like opposites, but they're doing the same comparison. In this one, group 1 was first, so we have a negative value. In this one, group 2 was first, so we have a positive value. But these are showing the same pairwise comparison between groups 1 and 2. In each case, our factors are significant. So this pair is significant. This pair is significant. That pair is significant. So if our first step was saying, hey, we reject our null hypothesis, there's a difference somewhere in kinds of adjustment, now we can use these pairwise things to say which ones were different. If we look at our graph, it helps us make sense of the different conditions in our data set. So within this particular test, there was a difference in adjustment. In fact, academic adjustment was harder because it had a lower value than learning to be independent, and learning to live with a roommate was lower than learning to be independent. Another way you could say this is students had the easiest time adjusting with learning to be independent, which was slightly greater, but significantly greater than learning to live with a roommate and their housing situation. And both of those were easier than learning to do the academic adjustment for college. Now, if we go back to the analysis, and instead of using the least significant difference, still wants those same three factors, what happens if we say, hey, instead of LSD, let's use Bonferroni? Bonferroni is, again, a little more particular. We're dividing that level and alpha level into several parts. So we have to find something really significant or really unlikely for us to call it meaningful. If we run the test again with a Bonferroni correction, then the first outcome, the omnibus F, will not change. It's still going to give us the same outcome that we had before, right? If we look at our degrees of freedom, same, F value, same, significance value, same. What happens is that we have different values sometimes on those pairwise comparisons, and it may suggest that some of the difference between pairs are not meaningful. Again, it's correcting for doing things multiple times. It's being a little bit more rigorous. And when we look at it this way with the Bonferroni correction, we see that academics was still less than learning to be independent, and academics was still less than learning to live with housing situations, but housing and learning to be independent did not significantly differ. A lot of times, journals will want the more rigorous approach and ask you for a Bonferroni correction. While as teachers who are just getting you to understand the concepts, will go with an LSD, more flexible kind of approach. What I'm trying to do is teach you about both and encourage you to be able, whichever one you pick, to interpret those differences. A Bonferroni correction and the LSD, what it's really doing behind it is running something like a dependent samples t-test to compare the groups between each of them. But instead of just running a bunch of t-tests, which increases our likelihood of making a type 1 error, or incorrectly rejecting the null hypothesis when we shouldn't, because we say something's there and really it's not, these post hoc tests are a bit more conservative approach and help us control for the likelihood of making a type 1 error, which is why we do it this way instead of just running a bunch of t-tests. But again, those pairwise comparisons are doing something like a t-test. Do these two groups, and those two groups, after we've seen if an overall effect occurs. Thank you.